today we are going to talk about VLANs and Q&Q, not specifically only about just VLANs because that would be too much of a basic topic, but I'll just brush up on what is exactly a VLAN. A VLAN is nothing but a virtual local area network wherein it helps ISPs or the enterprise networks or the branch networks to segregate their larger broadcast domain into multiple smaller domains. If you are from an ISP, you can use VLANs to segregate your regions or your different POPs. If you are an enterprise, you can segregate your branch offices or the departments that you have. Okay, so today I am going to talk about Q&Q VLAN, also known as VLAN double tagging. So this isn't exactly a basic topic, but it fits well within the networking series. Okay, so I thought I would share some thoughts about it with you. While this is somewhat DE-CIX specific, I encourage you stay tuned and definitely you are going to learn something new out of this. So now let's get into why do we use VLANs at DE-CIX? Traditionally, the DE-CIX peering product was designed to deliver peering services on an untagged Ethernet port. So this means that if you're connected to the Frankfurt peering service, you could simply peer in Frankfurt using a standard Ethernet port. However, with the introduction of multiple exchanges and the multiple peering LANs, their need arises to support multiple services over a single physical port. So to achieve this, we started tagging traffic with different VLAN IDs. So by using a trunked Ethernet port, customers could now access multiple peering services on one single physical port, with each service being identified with a different VLAN ID. So like you can see in my slide over here, there are different VLAN IDs tagged for different services, like the Madrid service is being served to the customer device on VLAN 30, or the Frankfurt peering service on VLAN 20, and the New York peering service on VLAN 45, just for your reference. With the introduction of the cloud services, we extended our VLAN tagging approach to include the cloud connectivity as well. So this means that on one physical port, customer can receive both the peering and the cloud services, each tagged with a specific VLAN ID. So for example, in this diagram, a cloud service is delivered on VLAN 500, okay, on the customer's port. Since the cloud providers often have their own internal VLAN ID ranges, we can handle the VLAN translation also in this case. So this ensures that the connectivity, even if the cloud providers require a different VLAN ID on their end. Okay, so you can see in this diagram, the cloud service provider has used a different 1833 VLAN ID, and the customer VLAN ID is also different on their device. So we could handle the different VLAN via VLAN translation also. So a similar approach applies to the peering services as well. If your customers want, they can choose their own VLAN ID to receive the specific services. We are open to whatever VLAN ID the customers is willing to opt, because there might be some conflicts with the service provider's network or the end customer's network or even the DE-CIX network. So we give this flexibility to the customers only, that whatever VLAN ID they might like, they can share with us and we can deliver those services on that VLAN ID. So now among the major what you can say, the cloud service providers, Microsoft Azure requires a special configuration. So let's take a closer look on how that works. Okay, so Microsoft Azure connects to DE-CIX infrastructure using two different redundant connections, a primary connection and a secondary connection. Okay, so for each customer, the same VLAN ID for each customer, the same VLAN is configured on both the connections to ensure that there is a seamless redundancy. But however, Azure uses its own VLAN ID ranges. We perform a VLAN translation also within our infrastructure. So this means that the customer VLAN ID on their side does not have to match with the VLAN ID that is being seen on the Microsoft Azure side. Okay, so the customer can opt for any VLAN ID that they choose, or their service provider if they are using a carrier partner in between. So like in this table also, you can see that on the Microsoft side, it's VLAN 100 and the customer is using two different VLAN ID tags on their side. So Microsoft Azure provides two types of peering services actually. That is the Azure private peering and Azure public peering. So both these services are delivered over a single express route connection ordered by the customer. So the challenge here is how to differentiate these two services on the Microsoft side and the customer side. So for that, the answer is pretty simple. That is VLANs, right? But there's a twist to this, because we already used VLANs to separate different customers, right? But to further differentiate what is the Azure private and the public peering over the same connection, we need some another VLAN ID tag also to it. So in that case, there's Q-in-Q, that is the 802.1 AD standard that we use for double tagging of that VLAN, which comes into the play. And there's an outer VLAN tag which is used to separate these customers. Okay, and the inner VLAN tag is used to separate the Azure private or the public peering service that the customer is using. So this ensures that the Microsoft can provide multiple services over a single physical connection while keeping the traffic isolated and also organized. Keep in mind, if you have multiple VLANs on one port, the Ethernet payload remains the same, that is the IP packets, while the VLAN tag is used to distinguish between the different Ethernet services on the same physical port. So by adding a second VLAN tag, Q-in-Q or double tagging, you can say, you can further differentiate the traffic effectively, allowing multiple logical VLANs to exist within a single physical connection. So this method is particularly useful when a service provider needs to manage separate different types of customers traffic over a shared infrastructure. Like for instance, you have a service provider through which you are taking a point-to-point connection from one data center like GPX for instance, and you are taking some multiple services from DE-CIX like cloud or the peering services or the map services. You don't have to tell the service provider every time that you have to use this VLAN for that service. The service provider can independently use a different double tagging method or a Q-in-Q tag for carrying your services to the other side of the far end, so that at the far end he could unstrip that packet to you and hand over the internal VLANs to you efficiently. So there is no intervention required from the ISP level as well. So let me show you uh, how the Ethernet frame structure changes when Q-in-Q or a double tagging is applied. So a standard Ethernet frame, that you know that there is a Ether type field present, then typically indicating for IPv4 it's 0x800, then for IPv6 it's 0x8622, or any other protocol for that matter, which is there on the Ether type field. But in a single VLAN tagging, that's .1Q, that the trunk port that you use to tag the multiple VLANs that you have, a VLAN ID is added to the Ether type field, mentioning the 0x8100 field. Okay, so this VLAN ID allows follows with a specific assigned VLAN ID also with it, so that whenever a frame reaches the other side, it comes to know that this is the particular VLAN tag that we had sent from the origin source also. But what happens during a double tagging, a second VLAN tag is inserted before the first VLAN tag. Like you can see over here, there is another tag that is added with the inner ether type that you already have, that is 8100, that is the inner tag, and there's an outer VLAN tag that is 0x8800 as an ether type to distinguish its service as a provider VLAN. Okay, so whenever there is a frame received on the either other side of the circuit, automatically the device comes to know that this is a Q-in-Q packet. Okay, the ether type is different, and accordingly the same services is being delivered to the customer on the other end. One more thing I want to tell you, that if you think that how devices generally process those Q-in-Q frames. So when a switch or a router receives a Q-in-Q frame, it first processes the outer tag, that was the 0x8888 tag. And once the outer tag is removed, the inner VLAN tag is revealed and processed accordingly. So this layered approach allows the service provider to separate customer VLANs while maintaining their own network segmentation, that is the outer VLAN tag, independently. So let's see how actually the double tagging work. So how does the tag gets added to the frame and where does this happen? There are few ways to do this. So let's consider a customer is directly connected to DE-CIX and the customer uses a router to connect to DE-CIX, and all the modern routers supports double taggings. Okay, so the customer sets both the inner and the outer tags on the router. So I'll show you an example of a Cisco router here. So one more thing, keep in mind that you have to keep the MTU size to the maximum. You have to keep the jumbo MTU for this case, because generally what happens whenever internet standard is used, 1500 of MTU size is generally used over the peering LAN or the transit links that you already have. But whenever a cloud exchange or a cloud service is delivered to any end user, generally a higher MTU size is opted because there's Q-in-Q involved and there are multiple providers in between, and also the cloud service providers also use Q-in-Q. So there has to be a larger MTU size to accommodate this request, because as you know that the 4 byte header which is stacked with the frame should accommodate in your existing packet size. So 1500 packet size is not enough for the frame to reach to the destination. So a higher MTU size is required to transfer accommodate the Ethernet frame with the two VLAN tags that I told you. So in this case, you can see there's a Cisco router example that I'm showing to you. The outer tag is used for the primary and the secondary connection. So it must come first, and you can have two different values to it. So DE-CIX translates these tags before forwarding this traffic to the Microsoft, because like I said, that this need not be the same in case of the Microsoft as well, that they might have given some other outer tag, and also the customer would be wanting some other tag that could also be translated. And the second being the customer has only one physical connection to DE-CIX but uses two different outer tags, one for the primary and another for the secondary connection. Okay. So next comes the inner tag. So inner tag, you can see here, this tag differentiates between the Azure private and the Azure public peering. The inner tag must be same for both the primary and the secondary connections. Okay. So this tag is only known to the customer and the Microsoft. DE-CIX or any other the transmission partner in between does not see it or does not modify it. Okay, because they ultimately we don't see it only. That you have to make sure. In Azure's case, they will only allow you a single VLAN inner tag on their portal. The customer has to assign that and they will receive it on the other end. So the customer needs to configure this on both on their router and on the Azure platform as well. Showed you an example of Cisco in this case, that the inner tag and outer tag. I'll also show you an example of how it looks in the Juniper router as well. So this configuration also applies to Juniper routers, where both the inner and the outer VLAN tags need to be set. So in this example shown here, I'm only demonstrating you the primary connection at the moment. For the secondary connection also it will be the same, only the outer tag will be different. So if you are connecting via an ISP, there may be many possible configurations who sets which tag. So I will not cover them all here. In this case, for example, if the ISP manages the outer tag, the customer needs to configure only the inner tag. Okay. So the ISP adds the outer tag before handing it the frames over to DE-CIX. Okay. So, however, this outer tag must still be present when the DE-CIX receives this frame, so that it should not be altered and it should be handed over the way it is to the CSP end. So since there are multiple ways to handle this VLAN tagging, if you have any questions, you can feel free to ask us after the session. We'll be happy to assist you according to your network, how you can utilize this Q-in-Q methods, or how you can deliver multiple services to your end customer. If you are an ISP, we can surely help you with that. Okay. So this is the example that I already told. The customer via an ISP is connected to this. There are several options that is already there to use it. So let's come to the conclusion. You have to remember a few points while setting up Q-in-Qs, that and also VLANs, that Ethernet is a broadcast networks, and VLAN IDs range from 1 to 4094 and can be used to deliver multiple services over a single physical port. And double tagging of VLANs allows multiple VLANs or services to exist within a VLAN. So this is how Microsoft handles the express route in case of if you are using or using the existing Microsoft Azure services express route, or any other micro modern router can also be configured to set both the inner tags or the outer tags simultaneously. But we have few customers also wherein their router is not capable to handle such Q-in-Q tags and unstrip the packet on their side. So in that case, what we do is, whenever we receive the frame from the Microsoft itself, what we do is we unstrip that packet and access the inner VLAN and hand over the inner VLAN directly to customer, so that the customer does not have to do a VLAN translation or a Q-in-Q VLAN unstripping of the packet on their side, if they have some device resource limitations on their side also, because some of the enterprise customers don't have such routers also. They usually take it over on a firewall interface, or they take it on a smaller branch router where they don't have such functionalities. So in that case also, DE-CIX helps the customer to design and deliver this link in such a way that there's a win-win situation for each and everyone. Okay. So that was it about for this presentation.
Thank you for watching.